Hello, everyone. Welcome to today's talk about Solr Anti-Patterns. I hope you had a great day yesterday at the conference and you enjoyed the party. And I hope you'll enjoy today's talk as well. So let me get started. Before we go into the talk, I would like to give a background. So basically, in Sematext, we give a consulting services as well as software engineering. And the talk today, it will be about one of the migrations that we did some time ago, not too long, that resulted in a few major mistakes. They had a major impact on the whole cluster that was migrated from the quite old Solr version to a quite new one. So that's mainly what the talk will be about. I'll try to show a few common mistakes we've seen during that migration, and that resulted also in some other clients' setup. We've seen the same mistakes being made. So maybe by giving the talk, some of those mistakes can be may not happen in case of your deployments. Before we start the meat of the talk, allow me to introduce myself. As I said, I'm a Sematext consultant and a software engineer. On consulting side, I help clients to overcome their problems, help with the architecture of search-based solutions. As an engineer, I work on our internal products, on external ones for the client as well. One of our internal products are the login, log centralization solution I work with a friend of mine who gave a talk just before me. I'm also a Solr PL co-founder where we share knowledge about Solr with a friend of mine. I'm a father and a husband, a father of 2 great kids. And I happen to actually write a few books, both about Solr and Elasticsearch. So basically, how the migration looked like. It was not so perfect as our client would like it to be, and actually as we like to work with the products and the projects. So you can imagine the Solr was migrated perfectly, nothing was changed, Solr started up after migration, and this is how we looked when we looked at the Solr configs. Actually, we threw our heads and, oh my God, what's about it? So basically, when we looked at the Solr config, before that, let me give you a bit of background on the migration. Wanted to jump too fast. So we started with our client with the Solr master-slave architecture based on Solr 3.1, which, as you may know, was released in March 2011. Our client wanted all the NRT functionalities, Solr Cloud, all the new features that were recently released. So the version they wanted to actually migrate to was 4.10, which was released in September this year. That gave us about 3.5 years worth of code changes and all the features that were added. One of the majors, like Solr Cloud, was introduced. The NRT functionalities, that all had to be used, and our client wanted to use that. So basically, when we looked at the Solr config, we seen things like that. Old Lucene 3.1 version. Old update handlers were still used. However, apparently Solr started. But they were used, and I'll show you what was the problem with them in a second. In addition to that, old directory factories were used. So that resulted in performance drops, both when it comes to searching and indexing. So basically, our client just took the Solr config, the old one, put it into Zookeeper, started indexing data, and as you can imagine, things blow up. Exception was starting to show. Their indexing application actually started to see something like that. So 400 status missing content stream. Oh my God, what's happening? On Solr side, on the other hand, we had a similar exception. So we said, let's take a step back, and let's update your Solr config to match what it actually should be doing. So we updated the Lucene version because they didn't need the analyzers to work in an old-fashioned way. We updated the directory factory to use the newest NRT capabilities. So, and this NRT caching directory factory is actually a wrapper around the mmap directory factory that can share the operating system file cache. So that's a big performance improvement when it comes to Solr. Of course, in addition to that, we needed to actually update the configuration of the update handlers. So we shouldn't use the old and deprecated ones. Instead, we should use the update request handler class and just specify the stream content type. And after that, in addition, we had two additional things. Of course, the update log for the replicas to be able to synchronize with the Solr, with the leader shards, and of course the NRT mode, which is by default true, but we don't like default values because they tend to change sometimes. So after that, everything should be working. We also took a look at the schema and noticed something that was coming back from the times where Solr had two between minor versions, and that was the int fields, the sortable int fields, and all these things. Again, that's a no-go, and you should upgrade if you have some fields like that. Instead, use the tree-based fields, which are faster and can be configured to properly and fast handle, for example, range queries, and be wise about that and perform it. After that, we've noticed that Jetty was actually also updated during the update of Solr. Before that, Jetty 7 was used, and after the upgrade, Jetty 8 was introduced. The thing is that with Jetty, the default configuration it has allows of maximum 200 threads per node. As you can imagine, when the indexing and performance query performance tests were starting, after a while, we've started to see the load dropping, and finally being 0, Solr stopped responding, nothing was happening, apparent deadlock. So we've looked at the thread dumps, and this is what we've seen. Block thread, block thread, block thread, as usual case of a distributed deadlock. That's happening because Solr can't actually communicate with each other because of the limitation on the number of threads that can concurrently run. So we said, again, no go. Let's step back, let's configure it properly, let's increase it to the value that is used by default in the Solr example deployment, so 10,000, and let's run again the performance tests. Everything was all right from that point. Threads were running, everything was nice. However, that was not the only thing that we've seen with the configuration. As usual, when someone is not too experienced in Solr or don't know about the architecture and how it should be doing, then using the embedded Zookeeper with Solr seems like a good way to save on machines. So what our client did is he actually had a Solr cluster and ran on one of the nodes embedded Zookeeper. And he pointed the rest of the Solrs to that one particular node. You can imagine that when that node fails, everything, almost everything stops working. You can still query your data, but apart from that, no cluster changes can be done. No leader elections, no indexing of data, no additional replicas or anything like that. That will be killed. So even with the small rolling starts of Apache Solr to upgrade to a minor version, you're not going to survive that. That's a no-go again. And we decided to go for an external ensemble of Zookeeper. That's a standard way to do that. Point each of the Solr nodes to that 3 particular nodes. That for that cluster, 3 was enough. So even with a single Zookeeper being down, we still were able to handle that, and Solr was still properly operating. And the same goes with Solr. Even if some nodes were down, we were still able to both index data and search the whole data corpus. Coming from Solr master-slave architecture, the usual thing, especially when the snap pooling was not that often, was the thing that we want to cache everything. But by everything, I really mean everything. So every filter, every document from the query, every result, and so on. And this is what actually was in our client's Solr config. Those are the real numbers. It worked in a master-slave architecture. That's because our client had from 30 minutes to 1 hour polling, so the warmup was not that problematic. The searcher was reopened once every hour, So once every hour, they had a higher load on Solr slave servers, but they could live with that because things were done as they were. With each slave getting the data fetching after one another. So, but with Solr Cloud, that really will not work well. That's because, as you can see, we had a warm-up times of almost constantly of 15 to 20 seconds. It means that Solr was constantly warming up data, and with, as I will show in a few, with a constant refresh of and reopen of a searcher object, it was not really usable, almost at all. So again, we've looked at the queries, talked to the client, justify why we want the changes to be done. And after that, we've figured out that those were the caches that we should use. The number of filters were far less from 1,000. Those were the distinct filters. It was still enough to not have evictions of the caches, so everything was nice. And the speed up we've gained with the warm-up times was about 7 to 8 times, because we finished with warm-ups between 2.5 to 3.5 seconds, which compared to the 25 seconds is, I think, a reasonable value to live with. So after that, we've noticed that indexing is not right. The indexing rate is very low, and again, we talked to the client, and we've seen why that's happening. They had a number of applications. Each document that was sent to Solr needed to go through a processing pipeline. Pretty simple one, but that took time. And actually, instead of having that in a single application with multiple threads, they have multiple JVMs spawned. So what that resulted in is actually putting a single document one by one from each of those applications without using bulks. So the documents were sent, and we were actually seeing about 20 documents per second being indexed, which is terribly slow, especially as they needed about 2,000 per second in a peak time. So nowhere near that amount. So what we said, this is not a pure Solr, but use a shared bulk pool that you will be able to put documents in and just send it and use multiple threads instead of multiple applications. And with that approach, only changing to bulk indexing, we were able to index more than 1,800 documents per second, which is a nice trade-off if you ask me, only changing the indexing strategy. However, after some time, we've noticed that the indexing dropped. Why is that? We looked again at Solr config, and we've noticed that the autocommits were adjusted. So we've seen something like that. The hard autocommit was set to 1 second with open searcher to true, and the soft autocommit, was set to 1 second. That meant that every 1 second, data was flashed to disk, creating possibly a new segment. And the soft autocommit resulted in opening a searcher. Actually, with that configuration, the hard autocommit will also result in reopening the searcher. That gave the Solr instance about 750 documents per second in indexing, which was not near 2,000, which we needed. So we again talked to the client and said a few things like, you don't need a hard autocommit because it's not a master-slave architecture. You don't need the hard autocommit and snapshot creating at all. The data will be replicated between the leader shard and the replicas in real time. So that's not needed. Let's lower the time because this is only about durability and we don't want to open the searcher. So we've increased the time of hard autocommit to 1 minute without opening the searcher, and the indexing rate jumped up 2 times, a bit more than 2 times. But it was still not 2,000 and more during peak times. So we said, how often do you need the data to be refreshed? The thing is that coming from 30 to 60 minutes of snap pooling time, going into near real-time mode is like comparing 2 different worlds to each other. When you had to wait for 1 hour for the data to be visible after indexing, and now you can live with, for example, 1 minute, that's a totally different experience. So we set that to 30 seconds, and actually we were able to index more than we needed during a peak time, so 2,200 documents. And that was all when it comes to indexing. We said, okay, let's stop here. We have enough. Better is an enemy of good. So let's put it away. Everything is working. Performance tests were nice until we looked at the queries. And when we looked at the queries, we've seen monsters like this. So this was a particular business use case. They needed to export data to an analytics system because that analytics system was not able to access that part of the corporate network to access Solr. So they actually needed to export the data from Solr once in a while. And usual thing, you start with rows equals 100, start 0, and you iterate through the results. And as you go, you see one thing, either a query time of 10 seconds, 12 seconds, and finally out of memory. Bah, everything stops working. Great, what to do? Use the scroll look. But why? Why is that happening at all? So when your application queries Solr, it actually needs to propagate that query to all the shards building the collections. Actually, not all, because there are replicas, but all the relevant shards, let's call it like that. That shards needs to return the documents to that one Solr instance, and a queue needs to be built, because we actually don't know where the documents that we are interested in that particular page of the results lives in. So again, we need to get them all, and that's why out of memory happens, because that amount of data may be just too much for Solr, and if there are more than, for example, a single query at the same time that needs memory. So as I said, instead, use the scroll. Use the cursor mark, specify the sorting, and you'll be good, because the performance of the querying will be nice, the memory footprint will be low, and you can just take it. The thing is that you just don't increment the rows and start. Instead, you use the cursor mark returned from the previous call with the next call, and you just iterate through the result. Anyway, that's not near rocket science, so a simple script should be able to handle that. In case you are using 4.10 Solr and you are using dog values, you can also use the newly introduced export feature of Solr that allows you to export the data in a single call. However, that requires the data to be pre-sorted. That needs sorting on a request, and only the fields that are using dog values can be exported, at least for now. That's a fairly new feature introduced in 4.10, and it's really nice, really performant with low memory footprint, however requires dog values, and actually the fields that our client needed to export was tokenized ones, so no dog values on those fields, and we didn't want to double the index size just because of the export functionality. So cursor was a way to go. The next thing that we've seen when it comes to querying was something like this. I'm not sure which is worse, the one with rows or that one. So basically, for the first time we've looked at the query log, we didn't notice that particular query. It was living somewhere, but that's something you shouldn't go for. When you see a query like this, you can expect, again, either a long query execution time or something like this, so an out-of-memory exception, because Solr will not be able to just handle the amount of data it needs to do. So basically, how we found out that something is wrong with the queries themselves when it comes to faceting. We've looked at JMeter results, and we've seen that the average query execution time is awful. It's more than 16.6 seconds, which is something not acceptable at all, at least for me, and the amount of data our client has. So we looked again at SPM, and we've seen that the network traffic is very high. But we looked as well at the request rate and latency, and look here. The average time for the queries reported by JMeter is more than 16 seconds. But actually, SPM, getting from what Solr gives it reports, and it's not visible too much, but it's about 2.6 seconds. So the discrepancy between the query time reported by JMeter and the monitoring solution is quite big. At least it should be more or less the same. So actually, why that happening? The pointer is the network traffic, because actually the data with facet min count 0 and limit equal -1, the thing is that it was done on the facet field that was a tag. It was a very high cardinality field, contained more than 1 million elements. And actually, each query that was run required all the values to be included in an XML response file. And you can imagine that 24 megabytes XML response for each query will saturate the network and it saturated the network during performance tests. That's why the discrepancy was so high. Because JMeter actually needed to wait for the network to be able to transmit the files with the results to the client. And after changing that, because our client actually didn't need all the tags returned with each document, we were seeing something like this. For that particular query pool that contained only faceting and was used to facet, we've seen a drop in an average response time to 1.7 seconds and increase in throughput for more than 4 times. So again, something acceptable, at least at that time. This was for a single node tests. And that's clearly visible how that's what the changes are in the SPM. We can see the before and after. Before we had a high network throughput, and after we have almost none. And this is the combined graph that you can look at, so it's clearly visible. The same goes with request rate and latency. However, in those two, not combined ones, it's not that visible, but we can see it here that after the changes, the throughput in the throughput was way higher than before. And finally, when we talked to our client about monitoring, they said, we'll go like this. So we look at the logs, we'll have some system-related metrics just monitored on our consoles, on our machines. And actually, they went for this until the first major breakdown happens. This is like like to differentiate people. Someone said a few years ago to me that people are divided for those who do backups and those that will do backups. The same goes with monitoring. You won't monitor your servers until the first really breakdown happens and you lose money because you don't know what happens. So that's why we said that you need actually a good dashboard to show you all the system-related metrics where you will be able to compare the before and after stuff. What are the changes? What is actually happening there? You need to see the documents, how they are indexed, what is happening inside your indices. You need to see the request rate and latency to be able to adjust your queries, adjust the number of servers, see what's happening, and if the search experience, at least when it comes to request latency, is nice, because nowadays no one will wait 10 seconds for a page result to show up. Google makes everyone lazy, and everyone wants us to return results immediately. Finally, you want all the JVM-related statistics, like the pools, like the garbage collection, and also you also want the system-related metrics, like network statistics, I/O, and stuff like that. Finally, last but not least, the filters are also very important when it comes to Solr. You need to know if the evictions are not killing the performance of the filters. And that can all give you an SPM, or that to not be only SPM. Like, you can also use open source tools and create a monitoring solution for yourself if you're not a fan of proprietary solutions like SPM, like we have the SPM one. So, for example, Ganglia can also be used to monitor Solr if you have time and resources to build it and configure it for your use case. So finally, a few words at the end, what to remember. During the work as a consultant for Sematext, we usually say to the clients that don't just take your old Solr configs and use them in the new version. Instead, it's better to use the one provided with an example Solr server and just adjust them and throw away stuff that you don't need and adjust the ones that you know needs to be adjusted. This is a good, especially good when you are not following Solr or any of those projects that are there constantly, because you are not on the top of things and you don't know what's changing, what it's needed, what's being deprecated, what shouldn't be used, what's the good practices, and so on. In addition to that, most of the problems that I showed today couldn't be avoided if the testing on developers' machines and in the test environments were done properly. If, for example, one wouldn't go into test environment when indexing wouldn't work at all. But apparently it was not tested at all, and they just went and rolled out the test environment and pushed the data, and oops, everything broke down. In addition to that, it's good to read release notes that are published with each release. Of course, reading release notes from 3.5 years, it's not something pleasant or not time-consuming, but sometimes even taking a look at those release notes will give you an idea of what's being changed between the versions. Both the minor ones and the major ones are like 3 to 4. And finally, Solr mailing list is your friend. If you are not subscribed, I really encourage you to do that because we are not alone around here. There are people with similar problems, and Solr mailing list is a very good point of contact, and the community around Solr is really great. So there are people who will really help. And that is what I wanted to talk about today. In Sematext, as my colleague said earlier, we are hiring. So if you're keen on working with the search technologies, with data analysis or logging related stuff, just give us a call. There are jobs opened for. So if you want to look at them, this is a friendly worldwide company, distributed, and we really like to work with you if you are nice and know the things. Thank you for your time. Here are the contacts for me and to Sematext. I encourage you to come to our booth and talk to us, play with the stuff we have with SPM, Login, and Search Analytics. Thank you very much for your time. Okay, we have time for questions. Can I ask for a microphone? Yes, here, then. Just a second.
Just a quick.
It's working.
Can you hear me?
Yes.
Okay, great. So it's a quick one regarding JVM tuning. So
yes.
With respect to going from 3 to 4x, are there just standard tuning parameters that you'll apply in starting up?
So the question is, did we tune JVM parameters between 3.1 to 4.10? We actually did, but it was not our work because our client had an ops team who did that. They actually only changed the JVM parameters most regarding the XMX and the heap size. Because after a few changes, we were able to drop down because they were starting with something on the old Solr slave servers. They were about 30 to 35 gigabytes of RAM needed because of those exports, facets, and stuff like that. We were able to tune that down to about 10 gigabytes, which resulted in a way lower garbage collection time and more efficient JVM working, because stop the word was not the thing. We also upgraded Java from 1.5 to 1.7 at the time. So, but this was not a part of our work, actually. We got the servers already upgraded. So that was the time, that was the case in this example deployment.
Thank you.
Thank you. Here's another question.
So, sorry, actually, there's one portion I didn't understand when you said fix the query, the limit. Can you go back to
the slide with limits?
Yeah, with
yes.
The one you think is correct.
Yes, here?
Yes. So you remove the facet limit equal to 1.
Okay, so the thing is that what we did, the initial query looked like as, let me get back to that initial query for a second. So that was the initial query. As you can see, the facet limit -1 tells that return me all the facets, and the min count equals 0 tells Solr to return documents even, to return counts, even if that, for that particular value of the faceting, there was no matched documents. That means that both using those both parameters resulted in actually Solr returning all the values for each query. For each query, all the values in that particular tag field were returned in the XML. So we can imagine even those that had count zeros. This is usually not the behavior you want, because you are usually interested in a portion of the facet values, usually the ones that are the most, that has the most documents, at least in the most cases. And in addition to that, you are not interested, again, in most cases, with in the names and the values that don't have any documents matched in that particular case. That's why we were able to, let me show that, to adjust that query to that actually family of queries to have a facet limit of 100, because actually that faceting query was used to show the left page on a site, where they actually give the users the ability to filter on the tags. So 100 tags was more than enough. They actually showed about 30 of them. And min count equals 1 resulted in the showing only the tags that really returned results after filtering. So that was the case.
Okay, thank you.
Thank you. Any more questions? I don't see. So once again, thank you for your time and enjoy the rest of the conference.